I'm excited to be here with all of you today to give you an introduction to iLogic. I remember the first time that I ever really thought about design automation was a few years ago when I worked as a design engineer in the waterworks industry. For this company, we would make these meter setters, and these are basically products that take the water deep down in the ground, and it brings your water lines up close to the ground so that they can install water meters and they can access that from the ground level. And when we got these orders from customers, it always took me quite a while to do the design because we didn't have any automation. And we didn't have any good design copy tools either. So basically, I would build all of these from scratch. And I remember at the time, every time I went through this design process, I thought, there has to be a better way to do this. And by better way, what I mean is a faster way. I mean a way that is more efficient, a way that's less error prone, and that is consistent from design to design every time that I had to do this. Unfortunately, at the time, I was a little intimidated by getting into design automation, so I never did that. And so what my goal is today is to give you an introductory look to iLogic that helps you understand that the automation nowadays, it's very accessible. We have great tools available to you that make it easy to go in and start thinking about how to automate your design process. So to start out, I first want to talk about some of the automation options so that you understand the different levels of automation that there are. Then I want to get into the iLogic interface, and then we'll do some part and assembly rules to show you how this works. Now, I do want to point out that today is really an introductory look into iLogic to help you get started. At the end of our presentation, there's going to be a survey, and if you want additional information, by express interest, we'll definitely send you that information. And in addition to that, we're going to have a class in a couple of weeks that Rich will be conducting. He'll be teaching that class. And during that class, you'll be able to do some hands-on exercises, and you'll be able to go into a lot more detail on seeing how the software works. So to start off, I want to, again, just talk about some of the levels of automation. Now, on the left side, we have the simple automation, and our scale goes to the right, where we get into more advanced types of automation that require higher programming expertise and more expertise in those types of areas. Now, on the left, we have geometry-based automation, and this is really about maybe using spreadsheets to drive parameters inside of your models. For example, you might have bolts. All of your bolts have a thread size. They have a length of the thread. They have a head. They have very common elements that if you put into a spreadsheet, you can quickly identify all the varying dimensions, the varying features of maybe 50 to 100 different bolts or screws that you might use within your company. And for that type of application, geometry-based automation is fantastic. Then moving up ladder, you get to rules and logic, and that's where you're able to put rules-driven logic into your designs. And that's where iLogic sits. And then there's a step above that, which is engineer to order. And this is about providing automation across the entire enterprise. So maybe on a pre-sales basis, you want to quickly generate accurate designs that have complete bills of materials and costing so that your sales can produce high quality, accurate quotes to your customers very quickly. But again, it's still something that has given huge returns to companies that have gone down this road of doing design automation. So I'm going to give you an introductory look today at iLogic by using a couple of different examples. In this first example, we have a head bushing flange. And with this part, I'm going to give you an overview of the iLogic interface. We're going to write a real simple rule so you can see how iLogic works. And the rule that we're going to write is, we want to give our customers or whoever's using our automation, we want to give them the option of choosing either a 5-bolt hole pattern, a 4-bolt hole pattern, or a 3-bolt hole pattern. And there's also this cut that we need to make in our flange, but we don't want our cut to cross over a hole. So if we have an even number of holes, we're going to want to put our cut over here, whereas if we have an odd number of holes, we're going to want to put our cut here at the bottom. So we're going to show you how to do that using rules in iLogic. After that, we're going to travel to a galaxy far, far away, and we're going to work at this fictitious Jedi Shop where we provide lightsabers for new up-and-coming Jedi that are being trained. And as you know, lightsabers are a very personal weapon, so they're going to want to customize and configure it to their specific likings. So we're going to offer 3 different models: our standard, our crossguard, and our dual blade model. We're going to give them some options on, the number of grips or fins that they want to put on their handle grip. And then we also want to give them the option of what color lightsaber they want to use. That way, if anyone chooses red, we know that we can keep a close eye on them because they might be going to the dark side. So let's go ahead now and let's jump into Inventor, and let's take a look at how easy it is to start using iLogic. Now, the first thing you might say when you open up Inventor is, how do I access iLogic, and how do I even begin to start creating rules? So if we come up to our Manage tab, we have an iLogic panel, and the most important tool is really this iLogic browser. This is going to allow us to see all the different rules that we create. It's going to allow us quick access to edit them and so forth. And I can take this, and if I want to, I can dock it right here with my model browser. Now, another key part to using iLogic is the parameter browser right here. And our parameters dialog is where, whenever we create parts inside of Inventor, it tracks all of these different parameters or dimensions, and these are created automatically as we generate our designs. Now, in addition to the model parameters, we can also have user parameters. And user parameters, we can name them anything that we want, and we basically use these parameters to drive our automation. So for our first example, the first one that we're going to be interested in is this bushing bolt count. And notice that we're limiting our options to only 3, 4, or 5. We don't want them to just choose any number of holes. And notice that as I change this number right here, it's automatically going to update and change my model. And you'll also notice that we have these 2 cuts here. And again, depending on the number of holes that we have selected, we want either one of these to be suppressed and the other one to be active. So here we have our odd cut. Again, that's the one we want to be active if we only have 3 or 5 holes. And here's our even cut that we want it to be active when we have an even number of holes. So let's go ahead and let's create our first rule. In order to create rules, I can right-click here and say add a rule right inside of my iLogic browser, or I can come up here and say add a rule here inside of my toolbar. Now once we add a new rule, we first need to give it a name, and we're just going to call this our cut location. And then our iLogic rule development environment pops up. And this is where we have a lot of tools that make it easy to access information in our model and create our rules. So up here at the top, you'll notice that I can access all my model parameters that we were looking at just a moment ago. And I can also access all of my user parameters. So here I have access directly to that bushing bolt count parameter that we saw had been created earlier. You'll also notice that I have a list of all of my features, and this is the same as the features that I have in my model browser. And this allows me to access important information on each of these as I need them to write my rules. Now over on the left here, we have basically these are code snippets, and this is a list of all of the different functions that we can use inside of iLogic. And notice that they're broken down into different areas that we need to access. So if we need to work on parameters inside of our part, here I can get and set parameters. We can look at tolerances. There's a lot of different options that we have. If I'm dealing with features, which in this case we will be, I can go ahead and I can double click this as active, and that will let me set the suppression or the unsuppressed state of any of the features that I have in my model tree. And this third area right here is where I actually write my rules. And if I'm not sure what the syntax is of writing rules, I have these little cheats right here where I can come down, and the first thing we're going to do is we're going to write an if-then statement. And I can double click on this and it will highlight so that we can go in and we can just simply make this rule. We can say, hey, if my bushing bolt count equals 4, and 4 is the only even number because we have 3, 4, and 5. So we can go in here and we can say that we want to make our feature this even cut. We want this one to be active. And so to be active, we say it equals true. And then we want our odd cut to be suppressed. And so we're going to go in here and pull up our odd cut, and we're going to make that suppressed by putting it equals false. Otherwise, or else, and notice here that instead of copying this over again, I can just simply copy it and paste it. And so we're going to change that one to false and this one to true to make it the opposite if it's an even, or sorry, if it's an odd number of holes. And now when I click OK, you're going to notice that because we have an even number of holes selected, my odd cut actually suppressed. And you can see that over here inside of my model browser. So now if I go back and I change it from 4 holes to 3 holes, notice that now my odd cut is active and my even cut is suppressed. And you can see that over in the model browser. So again, you can see it was very simple to go in and create a rule that governs how my part works. So now let's go and switch over to the lightsaber. And before we get too deep into the lightsaber example, I want to help familiarize yourself with the model here, just so that it makes the rules that we create a little bit easier to understand. So the way I have this set up is we have 3 different models that I mentioned before. So this is the standard model. And what I basically did is I arranged these components that we would need for each model type in its own folder so it's easier to follow. So notice that in my crossguard and my dual side components, those are all suppressed right now because we have a standard lightsaber. Now notice that my crossguard components are active and my standard and my dual blade components are suppressed. And then the same thing goes for the dual blade, where now we have our dual blade components that are unsuppressed. And that's basically what's going to allow us to configure our lightsaber in 3 different ways. We also have some parameters here. And these parameters that I have set up beforehand, and we're going to look at some of these rules. Notice that I can come in here and I can change the length of my lightsaber blade, and you can see that updating. And notice too that I didn't want anyone creating a super long lightsaber blade. So if you try to type in 50 or something higher than 36, it's going to automatically go back to 36. And we did some research. We found that 24 to 36 inch is our perfect range for a lightsaber length. So if I try to type in something like 10 inches, you're not going to win too many lightsaber battles with a 10-inch lightsaber. So I have it automatically default to where it makes it at least 24 inches. And we're going to see how I do that when we go and we look at the rules. Now, we also have the blade colors. So if I want to change it to red, we can do that. If I want to change it to green, we can do that here as well. And then I wanted to let our Jedis look at what their lightsaber will look like with the blade on or the blade off. Now, this lightsaber type, we haven't configured that yet. So right now, as I change it, it doesn't do anything. But we're going to add a rule in a few minutes that will make that work. So let's go ahead and let's take a look at how these rules are looking. So if I edit this blade length rule, notice that my first 2 rules are doing some error checking. And that's a great application of using iLogic. And basically saying, hey, if someone types in something greater than 36, then just make it 36 inches. That's the maximum we're going to allow them to do. And I could have a pop-up box come up if I wanted to alert them to that. In this case, I just set it for them. The second one basically says, now if it's less than 24, make it 24 inches. And so this way I can give them any option they want, but I can still control and keep it within a range that I want them to select between. Then once I verify that it's a valid length of my lightsaber that they're selecting, then I go ahead and I update my blade lengths for both the blade itself and then for the crossguard lengths, which we'll look at in a few minutes. Now for my blade colors rule, I want to open up my blade here for a minute so that you can see what's going on behind the scenes. If we look at our blade, notice that for my materials, I have 3 materials that are called clear, space dash, space, blue, then I have green, and I have red. So I have my materials defined inside of my part, and I'm actually going to set these materials using my iLogic rule. So even from the assembly, I can drive materials and other parameters down at the part level, which is one of the things that makes iLogic very powerful. So if I go in and I edit my rule, you'll notice that when we let them pick what color. We didn't say clear space dash space blue. We just told them what color they wanted. So here I have to create a variable. I call it my color of blades, and I make it clear space dash space, and then whatever color that they choose. Then once I get that set up, then I just simply change the material to equal that color that they chose. So again, just 4 lines of code, very simple. We can control the color of the blades both on the lightsaber itself and then on those cross blades that we're going to look at again in a few minutes. And the final rule I want to look at before we create our own rule is the ability to turn the blade on or off. And here at the assembly level, again, notice that we have some things that we can do with components. We can suppress or unsuppress them. We can replace components just like you can in the assembly environment inside of Inventor. We can change the color, or we can decide to make something visible or not visible. And that's the function that I chose for this specific rule. And we basically just said, hey, make the lightsaber blades and the crossguard blades, make them either visible or invisible, depending on whether we have this set to true or false. So again, very simple. If this is true, they show. If it's false, they're hidden and they don't show. They're not visible. So now we're going to go and we're going to write a rule. And the next rule that we're going to write, it's going to be called our lightsaber type rule. And this is where we're going to allow them to choose the type of lightsaber that they want to create. So this is going to require an if-then statement because we need to know what type of lightsaber they're creating. So if the lightsaber type equals standard, then there's certain components that we want to suppress and unsuppress, like I reviewed with you earlier when we brought up the model. In this case, we want the assembly projector part unsuppressed, and we want all of these other 7 parts suppressed. Now I could go in here and I could double click this as active, and it would bring it up here, and then I could go pick that specific part, and I could say equals true or false to suppress or unsuppress it. A faster way to do it is if I come in here and I right-click my top-level node, and I just say capture my current state. By capturing my current state, it goes through and it automatically shows me all my components and whether they're suppressed or unsuppressed. A lot faster to get that done. Now these first 3 parts, my assembly base, my assembly collar, and my lightsaber blade, these 3 are going to be the same regardless of the lightsaber type. So I don't need to suppress or unsuppress these. So I'm just going to remove these from my rule. And because I'm already in my standard state, it means that these are already captured the way that I want them to be. So this first one is active and all these others are suppressed. So now we want to go in and we want to add a second option. So here we use the else if. And again, we're going to go back and say now if our lightsaber type is, the next type is crossguard, then, and this time I'm going to, again, use just my copy and paste. So I'm hitting Control-C and Control-V. And now all I have to do is just go in here and update these on which parts should be shown and which parts should be suppressed. So I'm just going to unsuppress these 3 components right here. Got to make sure both of our cross guard blades are showing. And then last but not least, we need one more option here. And I could put another else if, but there's only one option left. So I'm just going to come in here and assume that the third option would be the dual blade. And for the dual blade, we just need to make sure that we include these bottom 3 parts. Now, one more thing that we're going to want to do is to make sure that the blade length, the blade colors, and the on or off of the blades are run through. We want to go ahead and we want to run our rule to make sure that those all get updated each time we change our configuration. So here I can just say, let's run all of these rules to make sure that we update our blade length. Let's make sure that we update our blade colors. And let's also make sure that we update whether or not the blade is turned on or off. So now when we're done, I can click OK, and immediately you'll see that it's going to update to show the crossguard style. And the reason it did that is because we actually have crossguard selected. So if we look over at our tree here, we can see it suppressed the right components and it unsuppressed the right components. And the same thing would happen if I picked dual side or dual blade. It's going to unsuppress and suppress the right components, and then back to standard. Now, also, if I go back to crossguard, you'll notice here that if I change the crossguard length, it's also going to update these crossguard blades. And last but not least, I can come in here, like I mentioned, I can turn on or off all of those different blades. So the last part that I wanted to show you, the last rule, and then we're going to create a form real quick, and then we'll finish our presentation today. We want to control how many fins are part of our handle here. So the first thing we need to do is we need to go to our parameters dialog, and we're going to create a new numeric value, and we're going to call this number of fins. And this is going to be unitless because it's just a number. There's no units attached to it. And we want to give it specific values that our user can choose from. And so the values that we're going to let them choose from are 6, 8, 12, and 18. And that way we limit the choices that they have. So right now it doesn't do anything. Again, it's just going to change. So we need to set this up with a rule. So now we're going to add a new rule called number of fins. And this is a really simple rule. All I have to do is go find that part, which is right here. And in there, I can access all of its model parameters. And a good practice is the parameters that you want to modify and change, it's good to change the names of those so that they're easy to identify and they're easy to use. So here I'm just going to double click my number of fins, and it automatically brings up the code that I need to access its parameters. So now all I have to do is say equals, and then come back up to that user parameter that I just created and say the number of fins in my part need to equal the number of fins that I've chosen inside of my assembly. It's really that simple. So now when I come in here and I change this from 6 to 12, it's going to go through, it's going to go down to the part level and modify my part so that it's valid inside of my assembly. So again, you can see iLogic makes it very easy. You can see it's very accessible to go in and to create these rules that let us modify our part. Now, the last thing I want to do is I want to show, before we've been modifying our part by going into our parameters dialog, but maybe you want to make it a little bit simpler and provide a standard form for them to make all of these options. So inside of iLogic, again, I can just right-click and go to my Add a Form dialog. And I'm going to bring this in so that you can see it. It provides me a preview, and we're going to go ahead and we're going to call this our light Saber configurator. So notice as I change the name, it shows me the preview of my dialog here. Over here, I have a list of all the different parameters that I use to generate these rules that configure and modify my lightsaber. So the first thing I want to do is I want them to pick the lightsaber type. And notice that I'm just literally dragging and dropping all of this information, and it's putting it right inside of my dialog. Now, these right here have to do with the blade properties, the length, colors, and status. So maybe I want to create a group so that I can put all of my blade options in a single location. So I can make this my blade options, then I can go ahead and I can put my blade length, my crossguard length, my color choice, and whether it's on or off, I can group that into this collapsible dialog right here. Now I also probably don't want like these underscores in there, so I can go in here and I can just change that right here. And then you can see that updates how it looks on my dialog. So now that I've created a dialog, let's go in here and notice that if I want to change my lightsaber type now, I can pick crossguard and it's going to update my model. If I want to change my blade length, I can change it back to 36. It's going to extend the length of my blade for me. So I can make all of these changes. But notice right here, if I want my blade status, it says true or false. It'd probably be easier if I could just make that a checkbox. So let's go ahead and let's go back into our form. And if I go down to my blade status, we have some options here. So instead of it being true or false dropdown, I can just make it a checkbox. That makes it very easy to turn my blades on or off. Maybe for my blade color, since there's only 3 options, I just want a quick list box that they can choose from. So here, accessing my properties for that, I can make that very simple to choose. And then one more quick example for the number of fins. We'll just make that a radio group, which lets me see all the different options and choose between them. So now when I pull up my dialog, it's a whole lot easier to read. You can see here we can more quickly decide, do I want my blade turned on or off? It's easier to understand. And we can more easily make these different selections on the number of fins or ribs that we want inside of our handle. So that concludes our demonstration portion of today. Just to summarize what we covered iLogic, how it fits into the grand scheme of being able to automate processes. And one other note that I wanted to make is that even along that spectrum that I talked about earlier behind automation, you don't have to choose just iLogic or just engineer to order or just using parameter-based tools. You can actually use all of them together where it makes sense. And that's the great thing about automation, is that it's like a toolbox. There are a lot of tools that we can pull from to make our process work efficiently as possible. So we reviewed all the different ways that we can automate. We looked at the iLogic interface. We did some simple rules and parts and assemblies to give you an introduction to how you create rules inside of iLogic. And then we created a simple form. So with that, I'm going to go ahead and turn the time over to Nigel, who is going to conduct our Q&A session.
The first question comes from, she is asking, when the components are suppressed, will they be included in the bill of materials?
No. When you suppress a part, it will not be included in the bill of material. So if you want a part not to be shown but want it to be included in the bill of material, then you would hide it and modify its visibility versus its suppression state.
Great. And then Aaron asks, will this particular assembly be available for download?
We can certainly make it available for download. It's non-proprietary. Obviously we don't have any Jedi services that will get upset at us. So yeah, we can make that available for you guys to reference.
Sure. So at the end of the presentation, there will be some poll questions. If you do want some more information about iLogic, you can definitely hit yes on that, and we'll add this Dropbox link too for the particular parts in addition to the other material that we have on there. Another question comes from Jeffrey. Can iLogic be used to drive documentation or drawings?
iLogic is built on Visual Basic, and with Visual Basic, if you have some type of a document, let's say in Word or Excel, then yeah, absolutely you can use Visual Basic to drive that, and you can actually put Visual Basic code inside of iLogic. So yes, there are also additional tools that I didn't review today. There's a tool called Configurator 360 that if you're interested in, we can give you more details on that. And that actually has some out-of-the-box tools that you can set up templates in Word properly, and it will automatically use the CAD models to generate quotes for you. So we do have some options there, even though I didn't review that today.
Jorg, our friend from Germany, asked during the presentation, he actually came a little late and wanted to know if you could catch up on the rest of it. You most certainly can catch up on the rest of the presentations. All of our AVA sessions get recorded and posted to YouTube shortly after. Laura Hansen has a couple of questions. The first one is, can appearances be controlled for assembly components the same way you've done materials? And what about appearance overrides for individual features or faces?
That's a good question, Warren. And the answer is yes, you can do both of those with iLogic. You can certainly activate a level of detail. You can use it to override the material or the appearance. Turn features on or off. You can change those features. So that's something that we're going to go over more in detail in our iLogic class. That's going to be starting in the next couple of weeks here.
Another one just came in. And how does iLogic work with copy design?
So there's a couple of different ways. So first of all, if you truly want to copy design, all of the rules are kept within the part itself and within the assemblies. So your rules are going to go over from one part to another as you do a copy design. There's also a way when you create assemblies inside of Inventor, where you place component, you can also place an iLogic component as another option. And what that does is it actually creates a new unique copy in your assembly directory that allows you to modify it without changing the original. So, you know, again, it works great with copy design, and it allows you to reuse those rules as you make new copies of your part and your assembly templates.
Also, we have an introduction to the Autodesk Inventor iLogic course, which is being taught by our certified instructor, Rich, who is over here. Rich, do you want to add some?
So again, that's going to be an intro class. We're breaking it up into 4-hour sessions over 4 days. And that's because we know that there's a time commitment that needs to be made, and sometimes it's not easy to get out of the office for a day or two, even if it is an online class. So that's going to start here on April 28th, and it's going to be 4 hours at the end of the day on Thursday for 4 consecutive weeks. And we're going to go a lot more in depth than what we saw here. We're going to use a uniform data set, so that way at the end of the class, you can really follow through the entire process and really create something that you can then take back to your office and use to customize your own workflow.
We'll see you all next week for the cloud computing AVA session. See you later.
Thanks, everyone.
Thank you.